Welcome back to the next biggest winner. In this segment, we'll be speaking with top-level management from Sonomax Technologies, Sofame Technologies, and St. George's Platinum and Base Metals. After we're done, each company is going to come back for a roundup discussion with our guest analyst. At no time in history have corporations and institutions ever been more focused on both cost and environmental efficiencies at the exact same time. One company that's delivering a combined solution is Sofame Technologies. They manufacture heat recovery and hot water heating systems. John, welcome to the show.
Thanks, George.
Let's talk about the fact that recently you put out your financials and you reported a profit about 5.7% for the first time in a long time, which is great news to investors who look for those kind of turnarounds. How did you achieve that? How did you finally move from a loss stage into a profitable stage?
Well, that's a good question. The company's been around for a few years, and what happened when gas prices went down in 2009, we had to absolutely reduce costs. So we just strictly reduced costs, outsourced our manufacturing, and we were able to close 7 orders last year and deliver 6 contracts. And with low overhead and good customers coming back to us, we were able to turn a profit. It's very important for the investors to see that. So I would say we're fully in commercialization mode now after 2 decades of R&D.
On the balance sheet side, though, looking at both sides of the equation, you're carrying liabilities in excess of $2 million. For investors out there who might take a look at your balance sheet, how are you guys addressing that?
Well, the most important thing last year was we generated $400,000 of cash flow. So from internal cash generation, we were able to keep our creditors happy. Most of them are trade suppliers. And they're partners in our business. They're working with us. They believe in our technology. We have a good product. And there are plenty of future prospects in the market with these suppliers. So they've been very patient about us paying our bills. And the fact that we were profitable only contributed to that patience. So now that we've reported a profit, we're negotiating with lenders. We've been looking for long-term lending for at least 2 years. And now that we're profitable, I think lenders are listening, and there'll be more news about that shortly. We're going to essentially refinance the short-term liabilities as long-term debt.
When you first started out, you had a utility invest millions of dollars in you at the R&D stage into the technology of the company. What kind of advantages did it give you over your competitors in the marketplace, and how important was that to getting you to where you are today?
I think the utility was Gas Metro, and their name is on several patents that we still maintain. They're shared patent holders, and we have a royalty agreement for those products. Okay. And I think they did the extensive testing with the Natural Gas Technologies Institute outside of Montreal, which is a federal funded operation for technology. And we have reports that prove the efficiencies of our products, and I think that was very important to the corporate customers we're selling to today to know that it's a proven technology. We're going into their power plants, and they don't take chances or risks in that area.
Yeah, and when I often look at companies for my own research, I don't just listen to whether they have great technology or not. The proof in the pudding is really, are their customers actually using the products? In your case, like I said, Princeton, Montreal International Airport, University of Toronto proves that people are putting their money behind your product.
That's true. And if it wasn't for the end users, the customers, in fact, advancing us funds to complete work last year with no bank financing, we wouldn't have been able to deliver. So I think we've done very well with the customers, and they're long-term loyal supporters of the technology. Once we start saving them money, those savings are there every year. That's why energy efficiency is a renewable energy. And when you save a hospital $500,000 on their operating expenses on an annual basis, they take it very seriously, and we support our customers. We don't leave any customers unhappy.
John, on that note, I can't wait to get you in at the end of the show back with our expert, David Danziger, who's very well versed in these. Welcome to the roundup portion of our La Belle Province episode of The Next Biggest Winner. Back here is David Danziger, our guest analyst, and all 3 companies. David, when you and I were just talking off-site here for a second, you and I both had the same question, and maybe you want to start off with the ROI question for John.
Sure. John, you've been pretty successful swimming around in this competitive green space. But what's the actual value proposition to your customers in terms of ROI, getting back? What do they actually? How do you actually come up with that savings for them, and what does it really amount to for them?
That's a great question. The answer is kind of stunning for most people. We supply heat recovery equipment to large boiler operators not small boilers, large industrial boilers like in food processing, hospitals, universities, and turbine operators that make electricity with turbines. And in those applications, anywhere from 20 to 60% of the energy, let's say natural gas, we like natural gas as a fuel because it's clean, goes up the stack as waste heat. So we recover that energy and we recirculate it in their process. And that's where the engineering comes in. It's not an off-the-shelf product. So we're able to reduce their gas bill by anywhere from 10 to 30%. And that represents about $150 to up to $1 million a year. And the payback on the fully installed system is under 2 years. That it has to be that today or we couldn't make a sale because expectations are really high among capital investors.
So you'd think it would be an easy sale, but it's not.
You'd think so. It's like heart surgery. You know, you want to know who your doctor is. We're in their power plant. It's a risky business, and the amount of analysis from a pharmaceutical company, for example, the amount of research they have to do before they change anything takes months and months, maybe years.
The guys you've hired out of New York, I guess, I take it they're going to be doing all these analysis for you to be able to find the ones that are attractive.
Through our board, we have extensive industry contacts, and we already have been negotiating for a year and a half with 3 companies that are for sale. And the total revenues already exceed the $50 million target. So it's just a question of they're at the show me the money stage, which is why I went to New York and I had to find a backer, which we did find.
What I'm hoping to do is really talk to you about the arc of history of energy at the Princeton University and use that not so much as an example of what you should do, but an example of the good thought process. I really stand on the shoulders of about 25 generations of engineers who've had my seat at the university, and I'd like to highlight some of the decision-making process that they made over the years. University of Toronto, they're celebrating more than 100 years of district energy. They're the ones who taught us how to take the heat from the exhaust of a cogeneration plant and dump it back into the returning condensate. They were several years ahead of us with the Sofame project. We're going to focus back on Princeton for a moment. Our sustainability program is that we will get from present levels back to 1990 levels by year 2020, or present levels of CO2 back to 1990 by 2020. We originally thought this would be a really stiff push-up. We thought this was going to be pretty hard to meet these. That was maybe 6 years ago. At this point, I can say we're fully confident we're going to get there. We have 95% fully defined. Many of these projects have already been implemented. Some of these projects are still in progress or in the engineering stage, but we know how we're going to get there. And at this point, it doesn't look all that hard. We've done project after project after project. We are not normalizing for square feet. We're not normalizing for the number of people on campus. This is sort of the acid test. As the campus has grown a couple million square feet, we have actually, in real terms, reduced our carbon footprint very significantly. That's the easy part. Now, if you accept the wisdom of today's global climate scientists, as I do, ultimately we need to get somewhere around 80% below current CO2 levels if we're going to stave off the effects of global warming. That's going to take a complete rethink of all the way we treat and the way we talk about energy in the country and in the world. We are the people who are going to do that. Really, we are the ones who need to teach everybody else how we're going to get there. Let's talk about reliability. Rob mentioned this a little while ago, but Princeton was literally the bright spot in the state when Hurricane Sandy came through. We were able to power the campus for several days when everything else was dark. We were able to open our doors and actually offer space for other people if they needed to come in and get warm, recharge their cell phones so that they could literally just communicate with one another. This didn't happen accidentally. It took years of planning. It certainly took some luck, but it also took a lot of people working very hard to get to that point. We're very fortunate to have on-site generation. It was really obvious that the lights stayed on. What wasn't obvious is the steam stayed on, the chilled water stayed on. If you're a researcher and you've got 10 years worth of glacial ice that happens to be stored in a freezer someplace, and that freezer rejects heat to the chilled water system, you'd really like that to stay working. No problems with that. The pessimist says the glass is half empty. The optimist says the glass is half full. The engineer says the glass is too big. Where's the waste? What's the opportunity? So let's look. What's on the desk today? This very messy desk, but I'll say, what are we looking at in our department right now at Princeton? We are looking at passive or near zero energy buildings to the extent we can. We're reducing the amount of energy that each existing building takes, and wherever we can, we're building the tightest buildings that we can. We're looking at fuel cells. I particularly like ones where I can recover the heat as well as produce electricity. We do have a value for heat, so we'd like both the BTUs as well as the KWHs. We're certainly looking at additional places where we can use renewable energy on campus. We're looking at ground source heat pumps. We have several different locations that we're considering. We have an apartment complex and another one that's being built. We have an arts district that's also going to be on ground source heat pumps. I'd love long term to be talking about a hot water loop. We're tightening up buildings. As you know, we're in the biofuels market. We're thinking about our trash. Where's the waste? Where's the opportunity? Could I make kilowatt hours out of that? Could I extract BTUs out of that so that it's not leaving the campus at all? And long term, we're thinking about water reduction. The whole conversation about energy is completely intertied with the conversation about water. And I expect a few years from now, we're going to be talking more about that at these conferences. District energy, most of you don't need to be sold on. It centralizes everything that breaks. It centralizes the tools. It centralizes the emissions. It centralizes the fuel deliveries. If I had 300 buildings that I needed to serve, rather than 300 boilers, now I can serve it with 3 boilers. Same thing, if I had, rather than 300 cooling towers, I could have 1 set of cooling towers. So all the people are in one spot, the problems are in one spot, and the opportunity to solve those problems are in one spot. I have a higher initial cost often, but not always, but I have a much, much better life cycle cost and a much lower carbon footprint. Here's the takeaway. Start wherever you are. If you have separate buildings, begin to interconnect them. Tighten up the worst ones first, and then use the savings to pay for the next steps, just as Bob was suggesting earlier. As you build a new system, what are the opportunities in that location? What can I imagine out of the very farthest time horizon? And if you have a mature system, look for the waste and let that inform you what your next job is. Thank you very much.